Greetings and welcome, friends. So we were talking about like congruence and transformations the other day, and there's actually a way to define congruence as there being a transformation or composition of transformations that will map one figure onto another. So here it says, identify any congruent figures in the coordinate plane. Explain. So let's see. I'm gonna pick this rectangle here, and I'm gonna say rectangle ABCD. Yeah, that is a. Fortunately, they named this in a sequence that's manageable, and there's probably multiple ways I could transform it onto rectangle this, but I'm just gonna say A is going to H and D is going to the L. So I'm going to call this HJKL. And the way I'm perceiving this is I think that there could be a translation that would have made that happen. This is, on the 4.4 packet about congruence. Yeah, you can still, you can write that down and still re-add your other problems and might be able to use this homework video moment to behave as your lesson for it, right? That might be sufficient. So let's see. This looks like A would have gone over 5, 6, 7. So vector 7, comma, and then it looks like it goes down 1, 2, 3, 4. So that's the vector that would have mapped those two together. Let's see. How about this triangle? This looks, it's a isosceles right triangle by the looks of it, right? Those side lengths are 3 and 3, 3 and 3. This diagonal, by the way, will be 3 square roots of 2. We'll figure that out later on in the course. And I'm going to say triangle Jeff is going to be congruent to another triangle. But let's talk about first what that what transformation might get you there. What do you guys think would get me there? What is this distance? 1, 2, 3.5 diagonals, and that's the same, right? Yeah, that's the one that I was thinking of. I think that you're talking about a reflection of y equals negative x, I think. Yep. Yeah, I think there's two ways. So I'm going to do the reflect over y equals negative x. And if that's the way that I translate it, then G is going to go to the R. So that's why I was waiting. And then E was the right angle, so that's going to be the Q, RQS is that. Your alternative would be 180-degree rotation about the origin. And in that case, G would have been rotated to the S. So you might have changed the order that you did your congruence in. But yeah, rotation would have worked there as well. And let's see, lastly, how about these adorable little triangles? Also isosceles by the looks of it. All right, okay. So yeah, could be a 90-degree or a negative 270 rotation. Well, rotations are always counterclockwise for positive angles. Oh, right. Oh, classic. Yes. Yeah, you could map. Yeah, it depends on which you were calling the pre-image and the image. I stand corrected. Yes. So yeah, let's do that. So I'll call this triangle MNP is going to be congruent to triangle, and we're talking a rotation here. And yeah, so 270 would be like that. So it looks like the M goes to the T. The N was kind of the, so N's going to the U and TUV. And rotate, we'll call that 270 or negative 90 about the origin. The origin. Excellent. All right, let's keep cruising here. Let's get out of here. Bam, next problem. All right, describe a congruence transformation that maps the blue pre-image. Oh, that's funny. Looks like blue is orange in my case, to the green image being the purple. You couldn't tell either. You're right. Yeah. Okay, that's fine. That's fine. So, I think this could be done in a rotation. Sure. Do you like it? This was Borderlands DOS, right? Yeah, yeah. I believe it. Let's see. SPQR. I've got 65 gold bricks in Lego Worlds so far. I need 100 Lego Worlds. Like, to be a master builder, you need to get 100 of them. Like gold bricks. Gold 2x2s. 2x2x1s, technically, but... Let's see, S goes to Z, P would go to W. I'm just trying to, we got to make sure these map in the corresponding locations. Q would correspond to the X and then the Y. Because in order for these figures to be congruent, that would mean that I need to name these in a way that the first two letters and these first two letters would actually be congruent segments. And notice that SP, which I think we all agree is an excellent Game Boy console, the Game Boy Advance SP, that these two segments would actually be congruent to each other, the same as the middle two, PQ and WX. Does that make sense? PQ would have been congruent to WX. Actually, in this case, those are congruent to each other as well. But yeah, so all the corresponding parts work out. Also, if I looked at any three letters combined, angle SPQ should be congruent to angle ZWX. So corresponding sides and angles are going to be congruent. And the way, oh, it looks like I did this the wrong way. I drew this is a negative 180 that I drew. But either way, it works this way too. So rotation 180 degrees about the origin. All right. Pick up the pace, Waddy. Let's go. Let's go. All right. Where am I at? Oh, lovely. It says if the distance between K and M is 2.6 inches. Let's see. K and M. Oh, here we go. Yep. So 2.6 inches. What is the length of C to C double prime? So that's the length we're talking about. And these two smaller parts are congruent to each other, right? This and this will be congruent to each other because that's the way reflection over those lines work. And notice that this distance of 2.6 is equal to one of the little ones plus one of the big ones, and that to do the entire distance, it's two of the little ones and two of the big ones, so it's just going to be double 2.6. 5 point, yeah. I started undoing it eventually. Also, my inch label looks like my double prime label there a little bit, but that is fine with me. And then similarly, if you have two non-parallel lines and you do a, oh wow, this is intriguing. All right, wait a minute. Okay, it looks like I'm reflecting A to this one, and then I'm reflecting that over M. And the question is, what would, nope, my bad. From the original, there we go, that's more believable. To this one, what would this angle be? This doesn't look to scale to me. But it's going to be whatever the acute angle is between those lines, you double it. So it's going to be 30 degrees is the answer. The angle of rotation. No, man, oh, Mr. Waddy. Terrible job. That is not a rotation, that's a reflection. It's between this one and that one. Oh. How embarrassing, my friends. I'm sorry. My apologies. That we can recategorize a double reflection as being the same as a rotation, and that angle is going to be double the angle, the acute angle between the lines. This is 30. Ah, my apologies, friends. Please forgive me. And then let's see. Lastly, and we can go over some of the other ones as well if you want afterwards. It says, tell whether the statement is always, sometimes, or never true. Here it says, if two figures are congruent, then there is a rigid motion or composition of rigid motions that maps one figure onto the other. What are your thoughts? Always, sometimes, never. I believe it's always. You also could have said dare, but no, always. And that's actually one of the definitions of congruent, that rotation postulate. No? Well, that might have been a specific type, but this is saying like any situation, even if it avoids a rotation. Yeah, but yeah, that's a specific type. And then let's see, the composition of two reflections results in the image, in the same image as a rotation. Now, yeah, sometimes in the times when the angle, the lines that are the lines of reflection happen to intersect, then yes. But if the lines were parallel, then no, that ends up being a translation, not a rotation. So it would not have been true in this case. And then if you happen to reflect it over the same line and then back onto itself, that also would have been no. So the answer here is sometimes. And have a great day, internet friends.